In this lesson, we focus on mathematics, Math 142 kinematics of a particle. We shall look at projectiles and a lot more and get started as follows. Right, we shall focus on certain parts of this chart that we could not finish last time. And I want us to focus specifically on, for example, this particular question here, question 4. Right, and question 4 is pretty much a very easy question, but we realized a typographical error here. So in particular, we noted that the acceleration should have been actually timed as 6 plus 0.02 s meters per second squared, and we did not actually obviously know that there was a mistake here until we actually obviously went on to do the question as it is, and we're just surprised why the result could not work out this way. But right now I want us to go through the question together and solve this question and show the time is actually correct. If the addition here, this term here is, so the summand is 0.02 s. Right, first things first, we need to note that the acceleration of a rocket traveling upwards is given by this, where s is in meters. And we need to determine the time needed for the rocket to reach an altitude of 100 meters. Initially, we have that the velocity is 0, the displacement is 0, and the time also is 0. I'm trying to make sure that we outline a clear method for solving this question. So to actually obviously solve this particular question, a couple of things we need to do. We need to realize that we have been given acceleration, but acceleration itself is dv dt, and this is 6 plus 0.02 s, and the units are meters per second squared. Not only that, but we need to know that velocity itself can be actually written as ds dt, like so. And this here means that we can be able to make dt the subject of the equation. And we have that dt is ds out of v, okay? Right, simultaneously, we actually can focus on the acceleration part. But the acceleration part is clear that if ever acceleration is dv dt, then we can make dt the subject of the equation, upon which we are able to obtain dv out of a. We ignore first this here, and we are just concentrating on the part on the left-hand side of the equation. Upon careful examination, we note that dt must equal itself. And so if dt equals itself, in other words, dt equals dt, and this means therefore dv out of a is actually ds out of v, like this. We cross multiply, and if we cross multiply, what are we able to achieve? We're able to achieve an equation that says v dv is a, right? We can write acceleration with the little line on top to show that we're dealing with a vector quantity. So this is sort of the sort of thing we have. Okay, this equation becomes very, very useful for us, and that is the one we need to use. So we actually use dv of v. Dv is actually a ds, which means we have v dv equals a. A is 6 plus 0.02 s, and we actually have ds this way. And now this means that we can take the integral on the left of this, meaning we have v dv is actually equal to the integral of 6 plus 0.02 s ds. So we have this, and whenever we have the integral of v, the v, it's the integral of 6 plus 0.02 s ds. And we integrate this and we get half v squared, which is 6s plus 0.02 s squared out of 2, like this. And obviously, upon looking at these very carefully, this symbol remains v. Upon looking at this very carefully, we're able to determine what we want. And what actually do we need here? So we need to look at this and ponder, because we need to determine the time for the rocket to reach an altitude of that much there. But now, what else do we know? We know that at this point, velocity itself is equal to ds dt. But obviously, we can multiply through by 2 here, getting v squared equals 2 by 6 is 12s plus multiply through by 2 is 0.02 s squared. Okay. We take the square root and we have v squared. We apply the square root on the left, but we also apply the square root on the right, like so. Right. And right, meaning our v is the square root of 12s, 0.02 s squared, like this, like so. Right, so now we have divided t, which is 12s, 0.02 s squared. Right, and upon looking at this one here, we're taking the positive, because you understand sort of that this moves in the same direction, in the upward direction. So obviously, if the rocket is sort of moving in the upward direction, that is sort of what you're going to have as a consequence. Okay, right. And if we manipulate this, what exactly are we able to, we have the following. Okay, right. Please take note of the fact that v itself is ds dt. Right, so v is ds dt. So if v itself is ds dt, then we have what we need here. We have certainly what we need. So which means that whenever we have ds, we can divide that by algebraic manipulations by 12s, 0.02 s squared, and this is dt. And upon careful examination, we take the integral of ds divided by the square root of 12s, 0.02 s squared, which is the integral of dt. And upon careful examination, we can get what we need. So meaning that we actually have the integral of ds divided by the square root of 12s, 0.02 s squared, which equals the integral of dt. And we have taken it from here. But upon careful examination of this, we actually have specific observations. And the specific observations are on the fact that we can actually be in a position to perform this integral here. But to perform this integral, we need to complete the square. Right, that is one thing we can do to actually be in a position to do this integral. We need to complete the square. And so to complete the square, we need to factor out right, the coefficient. So in other words, if you have 12s, let's work it out on the side here, and we have 0.02s. We factor out the 0.02, which means that we're going to have 12s, 0.02 plus, right, and plus, okay, this is s squared. This is s squared. So we have s squared like so. And now want to complete the square. So we perform further calculations. Let me see if we have the calculator. Okay, by good luck, we have the calculator launched. So now we can divide, for example, if you divide 12, you say 12 divided by 0.02, it's exactly 600. 600. So that in the end, then this is actually 0.02, and this is 600s plus s squared, meaning this is 0.02, and we have s squared plus 600. As you divide by 2, you get 300. In other words, we complete the square using the grade 11 technique. Right, completing the square using grade 11 technique, we shall have 600. Divide by 2, you square this, and you have 600, you divide by 2, you square this, so which is 0.02. And this is s plus, if you divide the 600 by 2, you get 300. And you square this, minus here you have 300. Because 600 divided by 2 is 300, you square that, you get exactly 900. Okay, we're good. And now we can continue to multiply by 0.02. 0.02. Anyway, we have completed the square here at this point, and meaning that when you get to this point, we have exactly ds. You divide by the square root of 0.02, and with s plus 300, like this, minus 900, like that. And this is the integral of dt, meaning that you have 1 over the square root of 0.02, the integral of ds divided by s plus 300 squared minus 900, which is the integral of dt. Right, so we have exactly that. So now we actually take this into account and we proceed to analyze this. So in other words, we actually therefore have 1 over the integral of the square root of 0.02, the integral of this, which is ds, divided by the square root of s plus 300. S plus 300, you square this, you subtract 900. Okay, this is much more than that, please. This is much more than that. Because if you check the 300, if you square it, it becomes more. Becomes like 90,000. So, which means that here we're going to have like 90,000. I'm glad I realized that a bit early enough. So, this is going to become like 90,000. So, meaning that here we shall have exactly 90,000. 90,000. Which means we have that, and this is 90,000. And this is actually equal to the integral of dt, like so. And upon careful examination, what then do we have here? Right. This is, well, what we have, but we can be in a position to sort of deal with this. But now we need to perform the integral of this, and the integral of this is quite a very interesting one. So the way to do it is to use further substitution. Right, meaning that we can let this one, so you can let, for example, or you can just use a U first. Let's use U and then use the rest of this. It's easier that way. I think you'll understand better as well. So for example, if you let, right here, let U be S plus 300, which means du equals ds. And if then this is the case, then you have 1 over the square root. All right, so this becomes exactly 1 over the square root of 0.02. Okay, right. And then now you'd have that ds is du, and this is the square root of the following. The square root of the following. So now this one is going to be exactly u squared minus 90. 90,000 equals the integral of dt. Okay. Okay. So what do we achieve here? Moreover, you need to use further substitutions. So you proceed to let. Now to integrate these, we use the secant function. So let u be equal to, now you need to take the square root of this one. So we need to take the square root of 90,000 and then multiply this by the secant of theta, so that du is 90,000 secant theta tan theta d theta, that way. But we know that the square root of 90,000 is 300. The secant of theta tan theta d theta. I'm trying to just outline the steps that are involved here, so that you can be in a position to sort of follow on what must be done. Right, and upon careful examination of this, what then are we able to achieve? Right, so this is 1 over. Let's check using a calculator. We might just be carrying this 1 over the square root of this, but it might be nicer. Okay, if you look at, for instance, 1 over the square root of 0.02. Okay, so that is actually 5 the square root of 2, which means that this one here, you can write it as 5 the square root of 2, then we have the integral of du. Right, and what then do we have here? Okay, let us simplify this one. So at this point, this is 1 over, what is the u squared? Right, the u squared, then you square this, which is 90,000. Right, and du is equal to what? Is 300. Du is 300. The secant of theta, tangent of theta, d theta equals the integral of dt. So that we have 5 the square root of 2. The integral of 300 secant theta, tangent of theta, d theta. 300 secant of theta, tangent of theta, d theta. Divide everything by, here you'd have therefore, let me see what we got here. Let me check everything we've got. Yeah, it looks fine. It looks so fine. Okay, we continue. So now we're going to have from under the square root, you're going to take out the square root of 90,000. And then we'll have second squared minus 1. Then you analyze that. So you'd have the square root of 90,000. And then you have the square root of secant theta minus 1. And this is equal to the integral of dt. But what do we know? We know that from high school, sine squared theta plus cosine squared theta equals 1. If you divide through by cosine squared, so you'd have the sine squared theta divided by cosine squared theta plus 1 is 1 over cosine squared theta, which means you have the tangent squared theta plus 1, which is the secant squared theta. Right, now, upon careful examination, it means therefore the secant squared theta minus 1. Whenever we have secant squared theta minus 1 is the tangent squared. But the square root of 90,000 is 300. So now, which means therefore we have exactly 300. The secant of theta, tangent of theta, d theta, the square root of 90,000 becomes exactly 300. And then now you have the square root of the secant squared minus 1, which is the same as the square root of the tangent squared. Okay? And then this is equal to the integral of dt. 5 the square root of 2. Okay, 300 cancels, and therefore you have the secant of theta tan theta. The square root of the tangent squared is the same as just the tangent. We are actually looking at reasonably very small angles to obviously have a lot of cases, and dt. So now what then we have here is that the tangent of theta cancels out, and we have 5 the square root of 2, the integral of the secant of theta, d theta. This is dt. Okay, so this is exactly what we have, and then we need to integrate this. So it means that if ever you have 5 the square root of 2, the integral of the secant of theta, d theta, is equal to the integral of dt. So everything sort of reduces to that. But at this point, we know the integral of the secant, okay, is the natural log of the secant of theta, the tangent of theta, and this is equal to the integral of dt is t plus c, right, like so. And now that we have got the integral, so we are actually very jubilant. We're very excited. But we need to remember what theta was, right? We saw that theta was introduced at this point. So we have a couple of things. So we have that u is s plus 300. But also u is the square root of 90,000 secant of theta. So in other words, we have that u is s plus 300. And then we also have that u is the square root of 90,000 times the secant of theta, which means that u is s plus 300, and u is simultaneously right, it's simultaneously 300, the secant of theta. And this means that u is equal to u, which means that s plus 300 is the same as the 300, the secant of theta. Dividing both left and right by 300 gives us x over 300, right? So s over 300 plus 1. Okay, so s over 300 plus 1. And once again, this is 0.02. Okay, also here it is acceleration is 6 plus 0.02. Because somebody can be like, what question are we doing here when they're watching the video? Because they can be like, you're doing a totally different question because the question is a single note. But we have this question here. So the acceleration is 6 plus 0.02. The acceleration is 6 plus 0.02. So yeah, we stated that here on this one. We're good. Let us continue. So now we have exactly that. So even here, we're saying the acceleration is 6 plus 0.02 s. Right, okay, we're still good here. So when you get to this point, we divide through by 300 so that we get exactly this, and this is actually the same as the secant of theta. We want to get theta, so which means that the secant inverse of s over 300 plus 1 is theta. So which means it is 5 to the square root of 2, the natural log of the secant of, now the theta is arcsecant of s over 300 plus 1 plus the tangent of arcsecant of s over 300 plus 1 equals t plus c. Okay. So now we got the answer up here, but we are not quite there yet because we need to just use some of these particular constants. Like we need to first get the value of c. Okay, right, but we have these initial conditions, and they are that v is 0, s is 0, when t is 0, which means that we have 5 to the square root of 2, the ln of the secant inverse of the following. Right, so we have this here, and this is exactly what we are able to achieve. It's what we are able to exactly achieve. So which means that whenever s is 0, you're going to put 0 here, giving us arcsecant 1 plus the tangent of arcsecant 1, and the t is 0, which means you have c is that. So now at this point, you have arcsecant of 1. Right, so arcsecant of 1 is actually what? Okay, so you need to think about this. What is arcsecant of 1? A couple of ways to think. So the secant of an angle theta is 1. What should theta be at this point? So we know that theta must be 0. Must be 0. Because we have that if ever the secant of theta is 1, that would mean that theta is arcsecant of 1. And therefore, theta is 0, which means that 0 is arcsecant of 1. And that means that we have 5 to the square root of 2. The secant of arcsecant of 1 is 0, plus the tangent. Arcsecant of 1 is also 0. And what is the tangent of 0? The tangent of 0 is 0. The secant of 0 is 1, which means that we have 5. This is the ln of 1, and this is 0. And therefore, this means that c is equal to 0. Now, if the constant is 0, then we're good. Then we come here and we plug everything at this point. We plug everything at this point in this particular equation here. Right, and in this particular equation, we have exactly what we want. So we have 5. Right, so we have 5 the square root. Right, meaning that we have exactly 5 the square root of 2, the ln of the secant of arcsecant of S over 300 plus 1, like this, and you have the tangent of the arc secant of S over 300 plus 1, and this is actually T. Right, and so as a consequence, what we have here becomes as follows. Right, and then now we actually obviously have put noted that C is 0. But simultaneously, we are interested in the altitude S equal to 100. Right, so S equal to 100. So S equal to 100 yields, or S equal to 100 meters. S equal to 100 meters yields the following. So S equal to 100 meters yields 5 to the square root of 2, the length of the secant, arc secant. So you put S equal to 100. So you put 100 divided by 300 plus 1. And then you have the tangent of arc secant, 100, 300 plus 1 equals T, which is this. Okay, now this is the secant of arc secant of this. So this is 1, this is 0, the zeros will cancel, giving us 1 over 3 plus 1. And 1 over 3 plus 1 would give us what? Would give us exactly 4 over 3. Plus the tangent of this one here, which is arc secant of also 4 over 3. Like that equals T. Okay, so we're good. Now at this point, we need to get the actual answer to this, and this will be the time. Okay, so it's a slightly interesting question, but yeah, you need to think a little bit. Okay, so we have 5, the square root of 2, the length of the secant of the arc secant of 4 over 3, plus the tangent of the arc secant of 4 over 3 equals T. And we want to get the answer to this. Right, and to get the answer to this, we need to, obviously we do not have the secant or the calculator, but we can use our knowledge of school stuff. So we're gonna let theta be, let this thing be theta, so that we can be able to get the answer to this. So let theta be arc secant of 4 over 3. And this means that because you can see the arc secant 4 over 3 appears both sides. So that now when you have secant theta is 4 over 3, like so. And when this is the case, we can actually be in a position to get what we want. So we actually come here and position this. So if we're dealing with the secant and we put it here and we put the angle theta here and we say using SOHCAHTOA, right? SOHCAHTOA, and then we also use Chaucher-Cow for the reciprocals, so that now the reciprocal of the cosine is the secant, which is hypotenuse of adjacent. And therefore the hypotenuse is 4, the adjacent is 3, and then this kind of a triangle. Right, so the hypotenuse is 4, the adjacent is 3, and then we need to get the y. By Pythagoras theorem, where 4 squared is y squared plus 3 squared, meaning that we have 4 squared, which is 16, equals y squared plus 9, which means y is equal to the square root. Okay, we obviously will take plus or minus 16 minus 9, and 16 minus 9 is plus or minus the square root of 7. So which means y is going to be the square root of 7, but yeah, we're taking only the positive there. Right, so now if this is the case, it means that when you get to this point, this is 5, the square root of 2, the length of the secant. So now this thing here, the arcsecant of 4/3, we call it theta. And then we have the tangent of this one, we call it theta. And then this is equal to t, like that. Right. So which means that we have 5 to the square root of 2, the ln. So what is the secant of theta from this diagram? The secant of theta from this diagram is the same as what? Secant is actually hypotenuse of adjacent. So hypotenuse of adjacent. So the secant is going to be 4/3 plus the tangent of theta. Tangent is opposite of adjacent from SOHCAHTOA. Right. From SOHCAHTOA, the tangent is actually opposite over adjacent. So, right, opposite. So I'm going to split this chart into different sessions because each of these is a bit lengthy, right? So that the tangent of theta becomes opposite of adjacent, and therefore opposite the theta is a square root of 7. The adjacent is 3, and this is equal to t, right? And in essence, it means therefore we can say our t is 5 to the square root of 2, the ln of 4 plus the square root of 7, you divide by 3 like that, and then you'll get the answer to this. Meaning that in the end, then you have the following, which means we have 5, the square root of 2, and then you multiply that by the ln of, you do this 4 plus the square root of 7, you divide by 3, and then you close. And then you press the equal sign, which is 5.62. And this gives us exactly the time that was obtained in this question. 5.624, right? Which means time is actually approximately 5.62 seconds. Right, so because of that, then this is the answer to this particular question. And so since this is the answer to this particular question, what you're going to do is, right, you can ask questions, but I know you might be having no questions because maybe it's very clear. Because each of these questions is long, what we're going to do is we're going to take a short break, and we shall therefore return in 15 minutes time, because each of these is long. So now we take a short break, and we're going to return at exactly in 15 minutes time. That is approximately at 5 minutes before 12. And then we shall start with the next question and then run through it like this. And in the process, I'm going to separate these recordings. Okay, I'm going to separate the recordings. Let me see.